6.5. Number 4. We have that the gravitational force is directly proportional to the product of the mass of two objects and inversely to the distance squared between the objects. Okay, gravitational force. Let's use F for the gravitational force. And it says that it is directly proportional to the mass of the product of the mass of two objects. So mass 1 is the first object, mass 2 is the second object, and their products, so they be multiplied. And I include my constant. Let's put an A for the constant, and it's inversely proportional to the distance between them squared. So inversely will be in the denominator. I will use D into a square. Now, furthermore, we're told that mass 1 is 5.98 septillion, so that's times 10 to the 24th power, and that's kilograms. The mass 2, which is the moon, that's the Earth and that's the moon. The moon will be about 74.8. It says sextillion, so that'll be 10 to the 21st kilograms. The distance between them, the Earth and the moon, will be approximately 0.384 times 10, let's see, it says million, so that'll be to the 6th power, and that'll be kilometers. And we're also told that the force that's between the moon and the Earth, that force is going to be 202 septillion newtons. Septillion is times 10 to the 24th power, and that'll be in newtons for N. Okay, and we're going to use these numbers right here to find out what the constant A is, so we can get the variation formula. So this will be 202 times 10 to the 24th power, and that's going to equal A, M1, which is 5.98 times 10 to the 24th. That's multiplied by, let's put a parenthesis here, another parenthesis here. The mass 2, which is 74.8 times 10 to the 21st power, all over the distance between them, which is going to be 0.384 times 10 to the 6th power, all squared. Alright, so I'm going to start simplifying this. First I'm going to do some expanding of the denominator, and then I'm going to regroup the numerators. Alright, so what we have here is 202 times 10 to the 24th power, and we'll make that equal to, we have our A here, and I'm going to put my 5.98 together with my 74.8, so times 74.8. Okay, then I'm going to group my 10 to the 24th and my 10 to the 21st. Group those together. Okay, this will be written twice, so what I'll actually have is 0.384 times 0.384, and this will be 10 to the 6 times 10 to the 6, so 10 to the 6 times 10 to the 6. Alright, and let's put all of that together. Well, I'm going to transfer all of this to the other side. So let's take the reciprocal of these and put it on this side. So what we're going to have is 202 times 10 to the 24th power together with our denominator of 0.384 times 0.384 again, and then the 10 to the 6 times 10 to the 6 here, and all of that will be over this as a denominator of 5.98 times 74.8, and we'll also have our 10 24th power times 10 to the 21st power, and all of this will equal A. Okay, now let's begin to simplify these. First, let's simplify these terms. Okay. So in the numerator, we're going to get 24 plus 6 plus 6. That gives me 10 to the 36th power. And below, when we put these two together, we're going to get 10 to the 45th power. Now, for the numbers that are left over, that don't have the base of 10, we're going to just multiply those in the numerator. So, I want to have 202 multiplied with 0.384 times 0.384, and after multiplying these three together, I'm going to get, let's see, let's make it a little darker. After putting those together, we're going to get 29.786. Okay. Now I'm going to multiply these two together right here. 5.98 times 74.8. And let's see, just clear this right here. And let's see, one more. 5 point. Okay, that's going to give me 447.3. Oh. Alright, looks pretty good. Okay, now I want to take these two and I want to divide those. So I have 29.876 divided by 447.30. And that gives me 0.06, and let's stop it right about here, 7. Okay. And when I subtract these, this will give me times 10. 36 minus 45, that's a negative 9. Okay. Now, to make this into scientific notation, I'm going to move my decimal behind the first digit here, significant digit, which will be 7.6. That was 2 moves, so that's to the second power. And this is, the original is smaller than the scientific notation, therefore we'll use a negative 2. And we have a times 10 to the negative 9. These two can combine and we'll get 6.7 times 10 to the negative 11th power. And this is the A. Therefore our conclusion is force is equal to 6.7 times 10 to the negative 11th power times m1 times m2 all over